Hello students, good morning. I hope you all are safe and healthy at your home. In our syllabus unit 4 we have remaining last 3 drugs: chlorpropamine, ibuprofen and sulfomonoxazole alpha or sulfoisoxazole. So we start with chlorpropamine. Chlorpromazine. Our drugs number 8 is chlorpromazine. Number 8, chlorpromazine. Chemically, it is 2-chloro 10 3-dimethyl aminopropyl phenothiazine. Chemically, chlorpromazine is 2-chloro 10,3-dimethyl phenothiazine, and we write this chemically name by structure phenothiazine. There are 3 benzene rings. Now this is 2-chloro and 10 3-dimethyl aminopropyl. I write structure, this structure about, and further write down because space is not enough on above. So I further write down this structure. This is 2-chloro and here number starting from here 1 2 3 4 5 6 7 8 9, and this nitrogen is 10. So here we write down CH2 and further CH2 and CH3. This is 2-chloro 10 3-dimethyl phenothiazine. Now we see synthesis of chlorpromazine. Synthesis of chlorpromazine. Synthesis of chlorpromazine. Metachloroaniline. First of all, starting material is metachloroaniline. This is aniline, NH2, and ortho and meta. This is metachloroaniline. Is treated with metachloroaniline is treated with orthochlorobenzoic acid. Orthochlorobenzoic acid. If we write down here, then this is ortho and this is also ortho. So this is orthochlorobenzoic acid. So starting material are metachloroaniline and orthochlorobenzoic acid. Orthochlorobenzoic acid. In presence of CuCl2, Cu2Cl2. In presence of Cu2Cl2 gives metachlorodiphenylamine. Metachlorodiphenylamine. Metachloro. On treatment with Cu2Cl2. Sorry, COOH is here. So this is metachlorodiphenylamine. Metachlorodiphenylamine. On carboxylation, when we heated this material at 250 degrees Celsius, so decarboxylation takes place and remove CO2. So we get metachlorodiphenylamine. 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 Also, we write this compound as 3-chlorodiphenylamine. 3-chlorodiphenylamine. Now, this 3-chlorodiphenylamine is treated with S2Cl2 or sulfur. S2Cl2. When 3-chlorodiphenylamine is treated with sulfur powder or S2Cl2 on heating, we get 2-chlorophenothiazine. 2-chlorophenothiazine. This is 2-chlorophenothiazine. And now in last step, 2-chlorophenothiazine, this compound is treated about above reaction. Now this 2-chlorophenothiazine is treated with is treated with 1-chloro-3-dimethyl aminopropane Cl CH2 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 N CH3 CH3. It is 1-chloro 3-dimethyl aminopropane dimethyl aminopropane in presence of NaNH2 in toluene, sodium amine in toluene. So condensation reaction takes place and HCl is removed and we get CH2, CH2, CH2 and CH3, CH3. Chlorpromazine. Chlorpromazine or chemically it is 2-chloro-10-3-dimethyl aminopropyl phenothiazine. So this is the synthetic route for production of chlorpromazine. I repeat, when metachloroaniline is treated with orthochlorobenzoic acid in presence of Cu2Cl2 and the product on heating about 250 degrees Celsius give metachlorodiphenylamine on decarboxylation. Now this compound on decarboxylation it is converted into 2-chlorophenothiazine is treated with basic compound 1-chloro-3-dimethyl aminopropane in presence of NaNH2 in toluene gives chlorpromazine. So we synthesize chlorpromazine by this synthetic route. Now its medicinal application. This chlorpromazine is sedative drugs, anti-emetic drugs and it is tranquilizer. So very important medicinal application of this chlorpromazine. Now our second one, number 9 is ibuprofen. Number 9 is ibuprofen. And chemically it is 2-para-isobutyl phenyl propionic acid. Propionic acid. Ibuprofen. Chemically, 2-para-isobutyl phenyl propionic acid, and if we write the structure, benzene ring in para position contains CH3 CH COOH propionic acid, and para-isobutyl phenyl. So on opposite position it contains CH2 CH CH3. It is ibuprofen. Ibuprofen. So first of all we see synthesis of ibuprofen. Mostly ibuprofen is synthesized by benzene. Synthesized by benzene. Ibuprofen is also known as Brufen. It is also known as Brufen. Brufen. It is an anti-inflammatory drug which is having antipyretic as well as analgesic properties. Ibuprofen is anti-inflammatory drugs, but it has some properties of antipyretic as well as analgesic property. It is indicated for the treatment of rheumatoid arthritis and osteoarthritis. It has been also recommended to arrest acute flares and in the long treatment or long-term management of this disease. So today ibuprofen is well-known anti-inflammatory as well as antipyretic and analgesic drugs. So first of all we see synthesis of ibuprofen. With the help of benzene, in synthesis of ibuprofen, benzene on treatment with isobutyl chloride. Isobutyl chloride, I write this is benzene. And second compound is isobutyl chloride, CH3 CH3 CH2Cl. This is isobutyl chloride. When benzene on treatment with isobutyl chloride in presence of anhydrous AlCl3. Anhydrous AlCl3, aluminium chloride or trichloride, gives isobutyl benzene. Isobutyl benzene. This is isobutyl benzene. When benzene on treatment with isobutyl chloride in presence of anhydrous AlCl3, we get isobutyl benzene, which is further treated with this isobutyl benzene is further treated with triethoxy acyl chloride. Triethoxy acetyl chloride in presence of AlCl3, and our reagent is triethoxy. So C2H5O 3 times. So this is triethoxy, and acetyl chloride CCOCl. This is triethoxy acetyl chloride. When treated with isobutyl benzene with triethoxy acetyl chloride, product obtained is reduced. On treatment with triethoxy acetyl chloride, we get intermediate step or this derivative of ester is then reduced in presence of reduction takes place. Palladium or carbon in presence of the product is reduced to give para-isobutyl benzylic acid. Para-isobutyl benzylic acid. So this is the structure of para CH2COOH. This is para-isobutyl benzylic acid. Benzylic acid. Benzylic acid. So if acid is not visible, I write here acid. It is para-isobutyl benzylic acid. Now it is with sodium ethoxide. It is treated with sodium ethoxide and sodium derivative obtained. We get sodium derivative when we treated with NaOC2H5, sodium ethoxide in presence of COOC2H5 twice CO. We get derivative of sodium ethoxide. Derivative of sodium ethoxide. Derivative of sodium ethoxide COOC2H5 twice. Derivative of sodium ethoxide, and this derivative is further treated with further treated with diethyl carbonate. Diethyl carbonate. Product is again converted into sodium derivative. So I rub out above reaction and we start with this sodium ethoxide derivative. This sodium ethoxide derivative is treated with sodium ethoxide in presence of methyl iodide. So this derivative is converted and I write down structure. Benzene contains CH2, CH, CH3, CH3 and this H is substituted by methyl group COO C2H5. We get on treatment with this sodium ethoxide derivative, it converted into sodium derivative now, and then we treated this with methyl iodide. Therefore, methyl derivative thus form. This is methyl derivative. Now, this derivative is subjected to two unit process. One is hydrolysis. When we take place, one is hydrolysis and second is decarboxylation. When this methyl derivative form is subjected to acid hydrolysis and then to decarboxylation, we get ibuprofen or brufen. Ibuprofen or brufen. I write the structure. Ibuprofen. So, by this synthetic route, we get ibuprofen. Further, I repeat, when benzene on treatment with isobutyl chloride in presence of anhydrous AlCl3 gives isobutyl benzene, which is further treated with triethoxyacetyl chloride. Triethoxyacetyl chloride. The product obtained is reduced to give para-isobutyl benzylic acid. Para-isobutyl benzylic acid. It is with sodium ethoxide. Sodium derivative is obtained and is treated with diethyl carbonate. Diethyl carbonate. The product is again converted into sodium derivative with sodium ethoxide and then treated with methyl iodide. Methyl derivative is formed, and in last step the form methyl derivative is subjected to acid hydrolysis and then to decarboxylation to give ibuprofen. So we get ibuprofen by this synthetic route. Now its medicinal application. Ibuprofen is used as analgesic, anti-inflammatory and antipyretic drugs. Here we have three uses as analgesic. Second is anti-inflammatory. And last one is antipyretic. So it is very important for medicinal use. Now our last drug is number 10, sulfoxazole or sulfomonooxazole. Sulfoxazole or sulfomonooxazole. Number 10 last is sulfoxazole or sulfomonooxazole. And chemically it is N,3,4-dimethyl 5,5-isoxazole sulfanilamide 5-sulfanilamino amino 3,4-dimethyl 5,3,4 5,3,4-dimethyl oxazole. Chemically, sulfoxazole or sulfomonooxazole is N,3,4-dimethyl 5-isoxazoline. Sorry, here I have mistake. Isosulfoxazole. Sulfanilamide 5-sulfanilamino 3,4-dimethyl 5,3,4-dimethyl oxazole. And if we write structure, then it is NH2 benzene ring SO2NH SO2, it is 2. SO2NH. 5-member ring. This is sulfoxazole or sulfomonoxazole. So we start synthesis of sulfoxazole or sulfomonoxazole. Sulfoxazole or sulfomonoxazole is obtained by ASC, acetanilide sulfonyl chloride, acetanilide sulfonyl chloride with aminoisoxazole. Aminoisoxazole. First of all, we write ASC, acetanilide sulfonyl chloride. Acetanilide sulfonyl chloride, CH3CONH, benzene ring, SO2Cl. This is ASC, acetanilide sulfonyl chloride. And it is treated with or condensing with NH2 3,4-dimethyl 5-amino isoxazole. When these two materials are condensing in presence of number 1 pyridine, and pyridine is with alkali in basic medium, when acetanilide sulfonyl chloride and 3,4-dimethyl 5-amino isoxazole is converted into sulfa isoxazole. So NH2 benzene ring, SO2NH, CH3CH3. Sulfoxazole or sulfomonoxazole. So it is synthesized by this route. Sulfoisoxazole is obtained by condensing ASC, acetanilide sulfonyl chloride, with aminoisoxazole in presence of pyridine by the alkaline hydrolysis of the product. We obtain sulfoisoxazole. Now, medicinal application. Sulfoxazole is soluble over a wide range of pH. It is very important property. Wide range of pH. So, it is used for infection involving sulfonamide sensitive bacteria. It is found to be effective in treatment of gram-negative urinary infections. Gram-negative urinary infections. So this is very important medicinal application. Here we complete our this synthesize part, and in this part we synthesize 10 number of drugs. 10. 1 mebendazole, second tolbutamide, third isoniazid, fourth metronidazole, 5 diphenylhydramine, 6 amphetamine, 7 chlorambucil aver, 8 chlorpromazine, 9 ibuprofen, and last one is sulfomonoxazole. Okay, thank you.